Chapter 11 of The Hurricane Hunters by Ivan Ray Tannehill. This LibriVox recording is in the public domain. Chapter 11, Tricks of the Trade. A gallant bark with magic virtue graced, swift at our will with every wind to fly, so that no changes of the shifting sky, no stormy terrors of the watery waste might bar our course. Dante. After 2 years of probing tropical storms by air, nearly everybody connected with the operation agreed that it was hazardous, but most of the men who were active in it had one main idea. As soon as the winds, rain, clouds, seas, and calm center of the average hurricane had been thoroughly mapped, a standard method should be devised for flying into the center and getting the vitally needed weather information en route with the least possible danger to the craft and crew. They thought of something like a football team, each man highly trained in a definite job with faultless teamwork, and all members of the crew on the alert every moment. Courses of instruction were organized. In all of them, one fact became abundantly clear in the first 2 years. No two hurricanes are exactly alike. All of them are big compared with thunderstorms and tornadoes, but some are much larger than others. The Recco crew may run into one in the uncertain stages of formation, and at other times they may be nosing into an old storm with strange and unsymmetrical parts. Of certain elements they were reasonably sure. All these storms have clouds, rain, squalls, and central low pressure, with strong winds spiraling more or less regularly in a direction against the motion of the hands of a clock. With these thoughts in mind, the instructors tried to devise methods that would prevent accidents. "What do you mean, accidents?" asked a junior weather officer at one of the conferences. "The whole thing is just one big accident, if you ask me. There's only one rule that's any good. Just be careful and don't fall in the ocean." As a matter of fact, most of the rules had that one vital thought in mind, but there were different ways of doing it. The Air Corps and Navy soon developed their own special methods. From the beginning, the Navy preferred the low-level method. That is, they flew by the quickest route to the calm center of the storm, going in at a low level, generally at an elevation between 300 and 700 feet. There are good reasons for this. Weather information, especially the facts they want about tropical storms, is vital to the safe operation of surface ships such as cruisers, destroyers, and minesweepers, and it is also used in the movement of aircraft from and to the decks of carriers. Task forces want to know about the speed and direction of winds at sea level, as well as the condition of the sea when storms are imminent. It was the aim of the Navy to keep their weather reconnaissance aircraft below the level of clouds, where the aerologist could watch the surface of the sea as much of the time as is possible within the limits of reasonably safe operation. When in a tropical storm, the aerologist guided the pilot around or into the center. Down near the water, say 100 to 300 feet altitude, turbulence is apt to be very bad, sometimes extremely violent. Above 700 feet, clouds are likely to interfere, and this was extremely dangerous at that altitude in those early years, because the altimeter, which they used to indicate height of the aircraft by pressure of the atmosphere, was sometimes badly in error in a tropical storm. If the pilot and the aerologist lost sight of the water's surface for a few minutes, they suddenly found the aircraft about to strike the precipitous waves of a storm-lashed sea. Pressure of the atmosphere falls with increase of elevation, roughly 1-inch drop in pressure for each 1,000 feet. If we put an ordinary barometer reading 29.90 inches in a plane on the ground and go up 1,000 feet, it will read about 28.90 inches. The pressure altimeter is a special type of barometer that shows elevation instead of pressure. When the pressure is 29.90 inches and the altimeter is set at 0, We go up to where the pressure is 28.90 inches, and it reads 1,000 feet. But if the pressure over the region falls to 28.90 inches and the altimeter is not adjusted, it will read 1,000 feet at the ground and be roughly 1,000 feet in error when we go up to where the reading is 27.90 inches. In ordinary weather, big changes in the barometer take place slowly, and there usually is plenty of time for correction. In a flight into a hurricane, big changes take place rapidly. The change caused by the plane going up may be confused with the drop in pressure in the hurricane. If the plane is in the clouds when these changes take place, the pilot may have a frightening surprise on coming into the clear again. More recently, the hunters have been equipped with radar altimeters, which give the absolute altitude for check. They send a radar pulse downward, and it is bounced back from the sea surface to the instrument. The time it takes to go down and back depends on the height. The higher, the longer it takes, and the instrument is designed to give the indication very accurately in feet. Thus, the radar altimeter removed some of the dangers of low-level flight. So the Navy hunters moved in at low levels, preventing the mush from becoming a splash, as they put it, and although their experienced pilots were marvelously efficient in flying on instruments, in clouds, or on the gauges, they kept the white welter of the storm-lashed sea in view whenever possible. Of course, it is not possible to fly straight into a storm center. The big winds carry the plane with them, and so the pilot might as well use the winds to good advantage. He will go with them to some extent, whether he likes it or not. If we examine ourselves in the center of the hurricane, facing forward along the line of motion of the storm itself, not the motion of the winds around the center, we know that the safest sector to fly in is behind us on our left, and the worst is in front of us on our right. At the left rear there is likely to be better weather, less dense cloudiness, and not so much rain. The winds are not so violent. So the Navy pilot flies with the wind. He goes in until he has winds of, say, 60 miles an hour. He puts the wind on the port quarter, and this carries him gradually toward the center of the hurricane. When he gets the wind speed to suit him, he brings the wind between the starboard quarter and dead astern, and flies ahead to the point where he thinks he has the best place to go for the center. According to Commander N. Brango, one of the Navy's top specialists in hurricane navigation by air, choosing the proper run-in spot is tricky business, for it is the point at which the wind is the reciprocal of the storm's direction of motion. The pilot must watch for this point carefully, as he may pass it quickly. If he does, there is imminent danger that the drift may carry the aircraft into the most severe quadrant of the hurricane. So the pilot goes into the center without wasting any time. Delay results in fatigue, and it is important that the men be freshly alert. The pilot puts the wind broad on the port beam, and he cannot possibly miss the eye. The next thing, the plane is in that amazing region where the sea boils, the breezes are light or missing altogether, the rain has ceased, and the clouds are arranged in circular tiers, like giant spectators in a colossal football stadium. This is a marvelous place. The crew is at ease, coffee goes around. In the last few moments before coming into the eye, the craft leaks like a sieve. Everything is wet, but the squirting from 100 crevices in the plane ceases in the center, and now it is possible to do some paperwork. The aerologist is busy with the weather code, and the radio man begins pounding out a message. They circle around. The pilot takes them up to maybe 5,000 feet altitude and back down again, circling around. And then the time comes to leave the center. The pilot calls a warning over the phone, and there are 2 or 3 wisecracks. But this departure from the eye is dangerous. The plane begins to catch the shear of powerful winds around the center. Here a man can get thrown around violently and be seriously hurt if he fails to get a good grip on something or neglects his safety belt. Now the pilot sets the wind broad on the starboard beam, and both he and the co-pilot hang onto the controls. This is rough going, and there may be some surprises, but after a little they are out of the big wind circle, and the navigator thinks the gales are down to something like 50 knots. The pilot sets course for the Navy airfield, and the staccato notes of the radio continue to carry vital weather information to the forecasters. On the subject, Captain Robert Minter, an old hand, at one time in charge of aerology in the Office of Naval Operations, is full of enthusiasm. He guaranteed that the Navy could get a ship off the ground on a hurricane probe within an hour after the Weather Bureau forecaster asked for the information. The Air Force has a different problem. Like the Navy, they are dedicated to the task of getting vital weather data for the forecasters, but their own problem is to evacuate military aircraft from threatened bases and get information needed for aeronautics. Also, they have the responsibility of giving weather forecasts and warnings to the Army. Until a few years after World War II, the Air Corps was a part of the Army, and when all three services were joined in the Department of Defense, the Air Force kept the weather job for both departments as a matter of economy and efficiency. Therefore, for this and other reasons, the Air Force follows a hurricane probing plan, which differs from the Navy's. Flying generally at higher levels in tropical storms, the Air Force, as much as the Navy, puts a great deal of reliance on radar, which has become a marvelous aid in watching the weather. In the beginning, years ago, radar was not designed for weather purposes, however. During World War II, radar was used to spy on enemy ships and aircraft in fog or in darkness to distances of 150 miles or more. The high-frequency rays sent out by the radar strike the object and are reflected back to the transmitter, where a sort of a silhouette appears on a scope. It may be black, with white areas showing images of solid objects, such as planes and ships. In those days, early in World War II, the weather was a nuisance to the radar people. It often seemed to interfere with the use of radar for military purposes, but the operators soon learned that the interference came from raindrops in local or general storms, and that the rainy areas could be located and followed on the scope, and with the proper design, the apparatus could be used as a weather radar. The first experiments with radar carried on board aircraft in organized tropical storm reconnaissance were made in 1945. Within 3 years, all the planes were carrying radar sets and had crew members whose sole business it was to watch the radar scope and tell the pilots and weather officers what kind of weather lay ahead. Scarcely had these observations begun when the radar weathermen discovered an amazing fact. On the radar, a tropical storm looks like an octopus with a donut for a body and arms that spiral around the body as if the creature had been caught in a whirlpool. These arms are bands of squally weather, oftentimes violent turmoil. Between the bands or octopus arms, the wind is furious, of course, but there is less turbulence and cloudiness, and here the aircraft is in much less trouble than in the squall bands. The cause of these violent bands spiraling around the center has not been figured out yet for sure, but all tropical storms have them, and the hunters are beginning to understand them better. The distance you can see from the radar station depends on how much weather there is. If there are large patches of dense rain, they may reflect all the rays back to the receiver, and none may go through to show other rain areas farther away. Because of this, the radar shows the eye of the storm, but usually not the entire circle of clouds around a distant eye. Not enough radar energy is left to reflect from the opposite side of the eye. For this and other reasons, it is necessary to have an experienced man to interpret the images on the radar scope. From a radar in an airplane at high levels, these limitations are not so troublesome. Recently, too, the range of military radars has been increased. Whereas the radar formerly was very useful in getting a view of the eye from the aircraft, it did not give the eye's geographical position, which had to be determined by other means, except when the eye was close enough to be seen from the coast. With increased range, the aircraft can get between the hurricane center and the coast or an island, and both appear on opposite sides of the radar scope. In such cases, the distance and direction of the eye from a known point on a coast or island can be figured. In the last 2 years, the Navy has used radar methods of this type extensively to obtain fixes of hurricane centers at night. In these instances, the crews fly at greater height than in daylight and can get the eye and the coast on the scope at the same time. This gives a good estimate of center location to supplement the daylight penetrations without flying into the storm center in darkness. Actually, night flights directly into hurricane centers were not profitable, as non-radar observations of sea surface, clouds, and winds were not possible in darkness. It is apparent that a plane going into a storm at some upper level soon gets into the clouds, and the sea surface is no longer visible. But the crew can depend on the radar to help find the center, and they can go down in the eye of the storm and look around, and, if necessary, the plane can descend in the outer parts of the storm and get estimates of the wind by a drift meter. For this latter procedure, the Air Forces at one time used what they called a low-level boxing procedure. On this, we can get the facts from the instructions issued by the head of the Air Weather Service, Brigadier General Thomas Moorman, Jr., a veteran of weather operations in World War II and in charge of weather reconnaissance in the Pacific, including the work done so effectively during the Korean War. In 1953, Moorman directed that in the interest of flying safety, there will be no low-level penetration of hurricanes. The Air Force pilots were asked to go into and out of the eye at the pressure level of 700 millibars, which under average conditions is at about 10,000 feet altitude. Within 100 miles of a landmass, the flights in a hurricane would be at a minimum altitude of 2,000 feet. To put it, in part, in the general's words, the hurricane mission would be conducted as follows. For high-level penetration, the first priority would be given to obtaining an observed position of the storm center, either by a radar fix plus a navigation fix on the aircraft position, or a position found by penetrating the storm and obtaining a navigation fix in the eye. The storm would be approached on a track leading directly toward the center. If the storm center could not be reached at the 700 millibar level, the low-level boxing procedure could be followed, but if the radar set was not operating, no attempt would be made under these conditions to go into the eye. For the low-level boxing procedure, the following instructions applied, quoting General Moorman in part. The storm area is approached on a track leading directly to the storm center and may be approached from any direction. As the winds increase in velocity, corrections will be made so that the wind is from the left and perpendicular to the track. The point at which the box is started is the midpoint of the base side of the rectangular pattern to be flown around the storm. When the winds of 60 knots are encountered, the first leg will be started with a 90-degree turn to the right. The low-level box will be flown within the 45 to 60 knot wind area, maintaining a true track for the first half of the leg, then a true heading for the succeeding legs. Surface winds should be 45 degrees from the right when the left turn is made to the next leg. Double drift winds should be obtained on each corner observation and each midpoint when practical. Reconnaissance of an area of a suspected hurricane will be flown with the same procedure. The weather observer will check the co-pilot's altimeter at frequent intervals to ensure that it is reading the same as the radar altimeter. All flights will depart storm area prior to sunset, regardless of the degree of completion of the mission. Flight altitude while boxing the storm will be a minimum of 500 feet absolute altitude, or at such higher altitude as will permit observations of the sea surface without hazard to safety. If contact flight cannot be maintained at 500 feet, the legs will be flown a greater distance from the eye. The boxing procedure was used a great deal by the Air Weather Service in the early years, but by 1954 it had been eliminated. The 700 millibar method was revised and, as used in flights out of Bermuda in 1954, was described by Captain Ed Vrabel, navigator, in part as follows. 1. The aircraft flies downwind at right angles to the storm path to a point of lowest pressure, about 20 miles, directly in front of the eye. 2. Flight is continued downwind for 3 minutes beyond the low point, and then the heading of the aircraft is changed 135 degrees to the left. 3. The aircraft continues on this course until the pressure begins to rise, and then turns 90 degrees to the left and into the center. This new Air Force plan of flying into the hurricane at 700 millibars, 10,000 feet roughly, is much like the Navy's low-level method, except that the Air Force crews enter downwind across the front of the storm, but this is nearly always an advantage for aircraft based at Bermuda. From that island, their most direct approach to an oncoming storm is into the front semicircle. The Air Force has another aid in measuring weather in a storm. It is an instrument called a dropsonde, a specially designed apparatus which works on the same principle as the older radiosonde. A marvelously ingenious instrument, the radiosonde is a unit of very small weight containing miniature instruments for measuring pressure, temperature, and humidity. It also has a metering device, a battery, and a small radio transmitter. The apparatus is carried aloft by a rubber balloon filled with helium. As the balloon rises, the radio transmitter sends signals for pressure, temperature, and humidity at each level reached, and the signals are copied on a register at the ground weather station. The dropsonde is a radiosonde that is thrown out of the aircraft flying at a high level and allowed to descend by parachute instead of being carried up by a balloon. There is a special listening post in the plane where the data are recorded as the apparatus descends. The data are then put into the form of a message for transmission by the plane's radio operator to the forecasting base. This work with a dropsonde is usually done by the radar operator in addition to his other duties. Much of this fascinating work is done by the Air Weather Service of the Air Force on routine daily flights, whether or not there is a tropical storm to be studied. As an example, they have made daily flights from Alaska to the North Pole and back to keep tabs on the strange weather up there. In this way, there, and in other parts of the world, they get weather daily from places on land and sea where there are no weather stations, no merchant ships to report, and no people to act as weather observers. These flights are named after some bird common to the region. The North Pole flight is called ptarmigan, others are called vulture, gull, etc. Special flights into tropical storms in the Atlantic and Caribbean are called duck missions. Some of these improvements in the hurricane hunting methods of the Air Weather Service were mentioned in a report by Robert Simpson, a Weather Bureau meteorologist who flew with the Air Force into Hurricane George in 1947. This was a big storm which appeared first over the ocean to the eastward of the Lesser Antilles. The squadron assigned to the job had been moved to Kendley Field at Bermuda. Simpson saw Lieutenant Colonel Robert David, who was in command, and arranged for the flight in one of the new planes piloted by an experienced officer, Lieutenant Mac Eastburn. Hurricane George, so called by the Air Force boys, although such names were not then official, moved slowly and menacingly across the Atlantic north of Puerto Rico and headed toward Florida. Simpson was in it several times with the Air Force. On the first flight, they were in an old B-29, which had too many hours on the engines and had been a bad actor on previous missions, but this time it behaved like a lady, and they picked up a great deal of useful information. On the next trip, they had a new plane. Here is a part of Simpson's story. Success is a marvelous stimulant. While we had every right to be near exhaustion after our 13 trying hours this first day in Hurricane George, we did not get to bed early that night. There was too much to tell and too much to discuss concerning the flight scheduled to leave early the next morning. This second flight promised to be even more lucrative of results than the first, for we were scheduled to fly in the newest plane in the squadron. It had only 100 hours or so in the air, and contained many new features the other planes did not have. Moreover, it had bomb bay tanks and could leave the ground with nearly 8,500 gallons of gasoline. There were a few changes in the crew, but Eastburn was the pilot again on the second flight. The takeoff was scheduled for 6:30 a.m. The storm was in a critical position as far as warnings were concerned, and the Miami office was anxious to get information as early as possible about which to base a warning for the East Coast. George was located over the eastern Bahamas and was moving slowly westward, a distinct threat to the entire eastern seaboard, but immediately to the Florida coast. The first hint of what was in store for the hurricane hunters that day turned up as they completed their briefing at the ship and prepared to board the plane. The engineer, in a last-minute checkup, found a hydraulic leak, and there was a delay of a little more than an hour before that could be repaired. Finally, they pulled away from the line and out to the end of the runway. Number 4 engine was too hot. There was another delay while further checks were made into the power plant. Finally, they were off, all 135,000 pounds. This was to have been a very long flight, and every available bit of gasoline storage had been utilized. The plan on this day was once again to make a try for data near the top of the storm, to verify and expand the startling information gained the preceding day. This plane had de-icer boots, and they were not concerned about the rime ice that might tend to accumulate as it had the day before. First, they were anxious to get certain data from a low-level flight, and to learn how effectively the radar could be used for navigating a large plane like the B-29 near the center of the storm. They went out at 10,000 feet again, but continued to a point about 80 miles north of the storm at this elevation. By this time, they had crossed about 4 of the spiral rain bands, the spiraling arms of the octopus. Here the plane turned downwind parallel to another of the rain bands and flew through the corridor to within a viewing distance of the eye. They gradually descended as the base of the middle-level clouds lowered near the storm's center. Leveling off at 7,500 feet, they were in and out of clouds with horizontal visibility low much of the time. However, there was scarcely a 30-second period when the crew were unable to see the sea surface below. Navigation at this stage was entirely by radar. Again, the amazing thing was the lack of turbulence throughout this flight. This was a really big storm. They were flying at only 7,500 feet through one of the most violent sectors, only 20 to 30 miles from the eye itself, yet they encountered nothing that could be described as important as moderate turbulence. Simpson's early experience in hurricane flying in 1945 in a C-47 had been repeated. They were flying in comfort under conditions which gave them a command of all the information needed to report the position and intensity of the storm. Simpson remarked, "What a difference this is from the battering flights at 500 feet in the B-17s, which have been standard operating procedure (SOP) with the squadron until this season." The fascination of flying in comfort so near the storm center tempted them to continue the exploration of reconnaissance tactics somewhat longer. However, there were many other important things to be done on this flight, and there was no time to waste. They picked their way across one of the bands to an outer corridor, and retreated to a point about 150 miles from the center, and once again began to climb. Perhaps in the fascination of traveling so close to the eye in such comfort, they had become complacent. In any case, the events which followed in fast succession left no room for further complacency. They had climbed no higher than 12,000 feet when someone spoke on the interphone with a bit of a quiver in his voice, "I smell gasoline." The hatches were opened, and the plane vented hurriedly. Eastburn went off to investigate and returned with a worried look on his face. He spoke to the engineer, who scrambled through the tube connecting the fore and the aft sections of the plane on the double. It was not until after he returned, about 20 minutes later, that the rest of the crew learned that they had developed a very serious gasoline leak in one of the hoses connecting the bomb bay tanks. Nearly 1,000 gallons of gasoline had been streamed through the bomb bay doors. The engineer had completed the repair satisfactorily, and after a brief consultation with the plane commander, the crew consented to go ahead with the project. "We climbed to 20,000 feet," said Simpson in his report. "I was seated on the jump seat between the radar operator and the engineer, looking through the tube. I saw from the tube a wisp of smoke drifting lazily toward the aft section. I do not recall my exact reaction, but I am sure I was not a picture of composure when I called this to the engineer's attention. Nor did he stop to check with the plane commander before demonstrating that he also was a handy man with a fire extinguisher. The cause was a simple thing. As we climbed, the engineer had turned on the cabin heater, the insulation of which was a bit too thin in the tube, so that the padding in the tube began to smolder. Perhaps this wasn't a very important item, but it didn't contribute to the peace of mind of any of the crew, especially when it was remembered that only a few minutes earlier the bomb bay gas tank immediately beneath that tube had been leaking like a sieve. Again the plane commander checked with the crew. Again, but with noticeable hesitation, it was agreed that we would proceed with the project. Higher and higher we climbed. This time we reached the 40,000 feet mark, with the base of the high cirrostratus still above us. So we leveled out, trimmed our tabs, and set our course for the storm center. This time we were determined to descend from 40,000 feet in the eye, to get a sounding there, and then return home at low levels. We soon reached the base of the cirrostratus and entered the clouds. The de-icers were working. Again the data began to roll in along the same pattern as observed the previous day, at least for several minutes, until the interphone was filled with the excited voice of the right scanner, with a spine-tingling report to the commander: "Black smoke and flame coming from number 4." At the same time the plane began to throb, roll, and yaw. In less time than it takes to say it, the boys in the front compartment of this B-29 became mature men, wise, efficient, stout-hearted men, each with a job to do, and each one doing it with calculated deliberateness, yet speedily. There was grim determination here, but no evidence of emotion. This magnificent tribute to top-notch training had an exhilarating effect upon me, and tempered to some extent the abashment which I could not help feeling as a result of my helplessness in this situation, and the fear which clutched my heart. We were lucky. The single carbon dioxide charge released by the engineer extinguished the fire in the engine. Number 4 was feathered and began to cool, but our troubles were far from over. The engineer had manuals and technical orders spread out on all sides of him, and was working feverishly to restore some power to Number 4, as the indicated airspeed dwindled from 168 to 166 to 164 or 5, hovering precariously above the deadly stall-out at 163. We were only a few miles from north of the center by this time, but no one had recorded the data. We were too busy worrying. The pilot was in the process of putting the plane into a long glide to increase the airspeed when the left scanner claimed the interphone circuit with "black smoke and flame coming from Number 1." This time we were in real trouble. However, the engineer had anticipated further difficulty, and was ready again. It was only a matter of seconds before the fire was out, and some semblance of power had been returned to Number 1. But we were still 500 miles from the nearest land, and very near the center of a granddaddy of hurricanes. So we declared an emergency, and headed for MacDill Field. Altogether, this was an ironical turn of affairs. An old plane had acted like a lady the day before, and now a new one had frightened the crew with its mechanical troubles. But the newer methods of hurricane hunting, like the tricks of the trade, had fortunately taken some of the danger out of the storm itself. Otherwise, the mechanical troubles might have combined with the weather to spell disaster. End of chapter 11.